Mastering decoupling control. Production control falls flat without a leader to isolate and liberate stages. Who is responsible for ensuring that the primary goal of decoupling control in a production environment, which is to isolate the different stages of production and enable them to operate independently, is achieved? In a production environment, the primary goal of decoupling control is to isolate the different stages of production and enable them to operate independently. This is achieved through the efforts of a multidisciplinary team, consisting of production managers, supervisors, and operators, who work collaboratively to ensure that each stage of production operates autonomously, but still in harmony with other stages. The production manager plays a pivotal role in ensuring that decoupling control is effective. They are responsible for overseeing the overall production process, identifying bottlenecks, and implementing strategies to mitigate them. This involves analyzing production data, identifying areas of inefficiency, and implementing changes to optimize production flow. For instance, if a bottleneck is identified in the welding stage, the production manager may introduce additional resources, such as personnel or equipment, to increase capacity and alleviate the bottleneck. Production supervisors, on the other hand, are responsible for ensuring that each stage of production is operating independently and efficiently. They oversee the day-to-day operations of their respective stages, manage inventory levels, and coordinate with other supervisors to ensure a smooth flow of materials and products. They are also responsible for identifying and addressing any quality control issues that may arise within their stage. Operators, who are responsible for executing the production process, play a critical role in ensuring that decoupling control is effective. They are trained to operate independently, making adjustments and decisions in real time to optimize production. They are also responsible for monitoring equipment performance, identifying potential issues, and taking corrective action to prevent downtime. In addition to the above, quality control personnel, maintenance personnel, and logistics teams also play important roles in ensuring that decoupling control is effective. Quality control personnel are responsible for monitoring and maintaining product quality, detecting defects, and implementing corrective actions. Maintenance personnel are responsible for ensuring that equipment is properly maintained and that downtime is minimized. Logistics teams are responsible for ensuring that materials and products are delivered to the correct locations, at the right time, and in the right quantities. To achieve decoupling control, production managers, supervisors, and operators use various tools and techniques, such as production scheduling software, visual management boards, and total productive maintenance (TPM) programs. Production scheduling software helps to optimize production flow, allocate resources, and minimize downtime. Visual management boards provide real-time visibility of production metrics, enabling quick decision-making and corrective action. TPM programs focus on proactive maintenance, eliminating defects, and reducing waste. In conclusion, achieving decoupling control in a production environment requires a collaborative effort from a multidisciplinary team. Production managers, supervisors, operators, quality control personnel, maintenance personnel, and logistics teams all play critical roles in ensuring that each stage of production operates independently, but still in harmony with other stages. By using various tools and techniques, this team can optimize production flow, minimize downtime, and ensure that products are delivered to customers on time and to the required quality standards. The pursuit of operational excellence. It's a journey, not a destination. I recall a fascinating case study that illustrates the importance of decoupling control in a production environment. In the late 1950s, I had the privilege of working with the Japanese automotive industry, guiding them on their quality journey. One particular manufacturer, let's call it Tokyo Motors, was struggling to optimize their production line. They were producing high-quality cars, but their process was inefficient, leading to downtime, waste, and variability. Tokyo Motors had a traditional, coupled production line, where each stage was dependent on the previous one. If one machine broke down, the entire line would come to a grinding halt. They wanted to improve productivity, reduce waste, and enhance overall quality. This is where decoupling control came into play. Decoupling control is about isolating each stage of production, enabling them to operate independently. This allows for the identification and correction of defects or issues at each stage, without affecting the entire production line. The goal is to create a smooth, uninterrupted flow of production, where each stage can operate at its optimal pace. To achieve this, we implemented a series of buffers and accumulations between each stage. These buffers acted as shock absorbers, allowing each stage to operate independently, while also providing a safety net in case of machinery breakdowns or quality issues. For instance, after the welding stage, we introduced a buffer zone where partially assembled cars could be stored temporarily. This decoupling point allowed the welding team to continue working, even if the subsequent stage was experiencing difficulties. Similarly, we introduced buffers between the painting and final assembly stages. The results were remarkable. Production downtime decreased significantly, and Tokyo Motors saw a substantial reduction in waste and variability. The quality of their cars improved, and customer satisfaction soared. Throughout this process, I observed that the key to successful decoupling control lies in understanding the intricacies of each stage and identifying the critical points where buffers can be most effective. It requires a deep understanding of the production process, as well as the ability to think critically and make informed decisions. As I worked closely with the Tokyo Motors team, I realized that our task was not just about implementing a new production strategy, but also about fostering a culture of continuous improvement. We encouraged employees to take ownership of their processes, to identify areas for improvement, and to propose solutions. In the end, our joint efforts paid off. Tokyo Motors transformed from a struggling manufacturer to a leader in the industry, renowned for its high-quality cars and efficient production process. As I look back on this experience, I am reminded that decoupling control is not just a technical solution, it's a mindset shift. It requires a willingness to challenge traditional thinking, to experiment, and to continually improve. The pursuit of operational excellence is a journey that demands courage, creativity, and a commitment to excellence.